Any doubts? Alright, I guess not. Can you guys see me? The light is enough or not?
Yes,
Yes,
sir, you
still
can see.
lagging.
Alright. So we finished cofactors in the last class, right?
Yes, sir.
Alright. Today we are going to learn about adjoint of a matrix.
Sir, you're still lagging, sir.
Alright. My voice is still breaking.
Yes, sir.
This I don't know the reason, but even my internet is fine today. Right? The video is not lagging, I guess. I don't know the reason for today's lag. Is it
No, sir.
audible or not?
Video is not lagging, sir. Only the voice is breaking.
I don't know the reason, yeah, Krishna. I don't know what to do. Like everything is like good from my side today, I think.
So maybe you can change the mic or something.
Actually, I've tried two earphones. Like in the last two classes, I changed 2 times. Even now, I'm using two, one for mic, one for like voice. Like I'm completely not understandable, or is it
So we
workable
can understand, sir, but it's like breaking something like continuously.
continuously? All right. I'll buy a new pair of earphones tomorrow. All right. Shall we continue like this today?
Okay, sir.
You can take off your earphones, sir.
Sorry.
You can take it off. You can do it without it, right?
No. My laptop would not hear that much. All right. And you are new here, right?
Yes, sir.
How are you?
I'm good.
All right. How much have you studied in other batch, or is this the first class?
This is my first class.
All right. So we have already finished matrices. All right, and few things about determinants. All right, Kusum.
Okay.
All right, and you can watch the recorded lectures. I guess you can ask for that. Right. So shall we start?
Yes, sir.
All right. So adjoint of a matrix. For this, you have to know how to find minor and cofactor. All right. So Kusum, do you know about that minor and cofactor?
Yes, sir.
All right. So what is adjoint of a matrix? Right from the definition, the adjoint of a matrix A equals to Aij is the transpose of the matrix Aij, where Aij is the cofactor of Aij, and it is denoted by adjoint of A. Right. Write it down. I'll explain. First, write it down completely. Are you done?
Yes, sir.
All right, everyone. Ronaldo, Kulsum, Shikani.
Done, sir.
Yes, sir. Done.
All right. So what this says is, first you find all the cofactors, all right, cofactors of all the elements, make a matrix out of that, take the transpose. All right. What this means is, if you have a matrix A equals to, this is A11, A12, A13, A21, A22, A23, A31, A32, A33. All right. The first step would be to suppose this is the matrix. The first step is to find the cofactor of A11. Let's write that A11. This is A12, A13. Right? You know this capital A represents cofactor.
Yes, sir.
A21, like A22, 23, C1, C2, and 3. All right. This step is the second step. All right. First, you have to find cofactors, then write it in a matrix. Now, adjoint of A would be transpose of this B matrix. All right. So transpose of this matrix. So this would be A11, A12, A13, A21, A22, A23, A31, A32, and A33. This matrix would be the adjoint of a matrix A. All right. So adjoint of a matrix A is also a matrix. Clear?
Yes, sir.
All right. Everyone clear how to find adjoint of matrix A? Kulsum, Krishna, Shikani, Ronaldo.
Yes, sir.
Yes, sir.
All right. You can write this down also. All right. Whoever has done writing, solve this question. Find adjoint A for A is equals to this. All right. We have solved this one. I'll give you a few minutes.
Done, sir.
All right. Everyone.
Yes, sir. Done.
What is the answer?
So 4 minus 3 minus 1, 2.
All right. Everyone, this is the answer.
Yes, sir.
Yes, sir.
All right. No doubts here, right? All right, I don't need to solve this then. Okay, one thing you must have known. Tell me the answer again. Anyone?
4 minus 3 minus 1 and 2.
So you can write this in note that adjoint of a matrix of order 2 can be found by replacing A11 with A22 and A22 by A11, A12 by A21 with changing its sign. And vice versa. What this means is just change the sign of this and this, interchange these two. You'll get the adjoint. Right? Here also you can check 4 is written here, 2 is written here, 3 is written here. Sorry. Is this the right answer, everyone?
Yes, sir.
Let me check. Factor of 3. Yes, then don't interchange this, just change the sign. Okay. This is clear, everyone?
Yes, sir.
sir.
All right. Chikhani, you are not responding at all. All right. We'll be with Chikhani later. Let's move on. Next question. Example A. A is 4, 5, 6, 7, 8, 9. All right, try solving this.
Done, sir.
Everyone solve this? Also, Ronaldo, have you solved this?
Not completely sure.
Right, I'll give you 2 more minutes. Everyone can solve this question?
Yes, sir.
All right. Ronaldo,
Sir, I have problem with this. So can you solve it?
all right. Kulsum,
Done, sir.
done. All right. See, Ronaldo, you just have to find first. You can solve a M11, M12, M13. Have you solved this?
So M11 will be 5 into 9 minus 6 into 8.
5, 9, right. So 5 9s are 45, right? 48. So this is minus 3. And what is M12?
M12 will be M12 will be 4 into 9 and minus 7 into 6.
And what is the answer?
4 nines are 4 nines are 36 minus 7 6 are 42.
And so that will be minus 6, right?
Yes. And
And
then
Ronaldo, what is
M13 will be 4 into 8 minus 5 into 7.
right? So this is again
4
it
eights
is
are
minus
32 minus 7 into 5 is 35.
right. And now let Ronaldo answer. Ronaldo, what is M21?
So 9 minus.
And you tell me just the final answer.
So, sorry, sir.
Just tell me the final number. What should I write here? M21 is M2 would be 18 minus 24, that is minus 6.
18 minus 24.
So minus 6, sorry, just tell me minus 6 like that. So M2 would be Krishna, what would be M22?
Sir, it would be
Minus 12.
minus 12.
Minus 12. And M23?
So it will be minus 6.
Okay. Did you guys directly found out that cofactors?
Yes.
All right. You can do that also, but more precise step would be to find minus 10 cofactors. All right. So M31, M32, and M33. Tell me the answers here.
-3.
Minus 3 here,
Minus 6.
minus 6. M3
Minus 3.
Minus
basically would be minus 3. All right. Now cofactors. All right, Shivani. I'll try to do that. All right. Cofactors A11, A12, A13. Tell me the answers fast.
So minus 3, 6, minus 3.
A21, A22, A23.
6 minus 12, 6.
All right. A31, A32, A33.
Minus 3, 6, minus 3.
Everyone, this is the same answer.
Yes, sir.
All right. Now, Ronaldo, after finding cofactors, this is clear, Ronaldo? Clear cofactors?
Yes, sir. Yes.
All right. Now you have to write a matrix. All right. Of this cofactors. So this would be minus 3, 6, minus 3, like this. This is the first row. All right. Now 6, minus 12, and 6, second row. Then third row. All right. And transpose of this matrix would be adjoint of A. All right. Write this matrix, take the transpose. So minus 3, 6, minus 3, 6, minus 12, 6, minus 3, 6, and 3. This will be the answer. All right. This is clear.
Yes, sir.
I guess this is minus 3. I forgot the minus here. This is minus. Okay. This is the answer, everyone.
Yes, sir.
All right. So I hope adjoint of will be clear to you, because we are going to need a lot of the questions where we need to solve this. Now let's write a theorem. Let's see what the theorem says. Theorem says let A be a matrix of order, a square matrix of order n. Then A times adjoint of A is equals to adjoint of A times A, and that is equals to determinant of A times I, where I is the identity matrix of order n. Alright, very important theorems. Alright, don't try to like forget this. This is very important. This is saying if you multiply a matrix with its adjoint, what you get? Determinant of that matrix times identity matrix. All right. This is very simple. If you multiply one matrix to its adjoint, then what you get? Determinant of that matrix times identity matrix. All right. Is clear, everyone?
Yes, sir.
Okay, Kulsum.
Yes, sir.
All right. Note it down. All right. Everyone note it down this theorem 1.
Yes, sir.
All right. So theorem 2 says if A and B are two matrices and they are non-similar. What does non-similar mean, Krishna?
So whose determinant is not zero?
Non-zero, right? So A and B are such matrices that their determinant is not zero and they are of the same order. Then if you multiply both AB and BA, then they are also non-similar matrices of the same order. All right, this is clear.
Yes, sir.
Right, write this down also. All right, done.
Yes, sir.
So theorem 3 says the determinant of product is equal to the product of determinant of individual matrices. This is a simple theorem that means AB determinant is equals to determinant of A and determinant of B. Very simple. All right, nothing complicated here. This is clear to everyone.
Yes, sir.
All right, Ronaldo, Kulsum, Shikani, this is clear.
Yes, sir.
Yes, sir.
All right, write it down.
Done,
Done
sir.
everyone? All right. This is the last theorem, theorem 4, and this is the most important. You can put as many star marks as you want here. This is saying if A is a non-single matrix of order n. All right. Suppose A is a square matrix of order n, then determinant of adjoint of A is equals to determinant of A to the power n minus 1, order minus 1. All right, this is very important. You can get 1 mark questions from this or proof. They can ask for proof also. All right, so let's see proof. All right, we know that A times adjoint of A is determinant A times I. This is theorem 1. Right, I told you in theorem 1 that A times adjoint A is equals to determinant A times I. Right. Now,
Yes, sir.
I can put the value of I here. Suppose A is a matrix of order 3. So this will be 1, 1, 1, dash dash 0. This is clear, everyone?
Yes, sir.
Yes, sir.
All right. Let's multiply this determinant A to this matrix because this is a scalar quantity, right? Determinant of a matrix is a number. So we can multiply this with the matrix. So we can get A times adjoint of A is equals to determinant A 0, 0, 0 determinant A 0, 0, 0 determinant A. Right? Any scalar multiplied to any matrix is multiplied to all the elements. Right, Krishna?
Yes, sir.
All right. Now I can take determinant both sides because this matrix and this matrix are equal. So determinant must be equal also. So determinant A times adjoint A is equals to determinant of this. Right. Now theorem 3, I guess. Multiplication of two matrices and taking determinant is equals to their individual products. And now if I have to take this determinant A outside of this row and this A outside of this row and this A outside of this row, then out of this determinant I will get 3 determinant A. This step is clear or not? Is this step clear everyone or not?
No, sir. Can you explain it?
All right. If you multiply 5 to any determinant, what happens to this 5? Krishna, if I have to multiply this 5 to this determinant, then what happens?
So it is multiplied to its cofactors.
No. You can multiply this 5 to any row or any column. Remember this I told you?
Oh, yes, sir. Yes, sir.
This is clear. Ronaldo, this you remember? Ronaldo Kusum, this you know, if any scalar is multiplied to any determinant, then this scalar is multiplied to any row or any single column. Like in matrices, that number is multiplied to each and every element, but not in determinant. In determinant, pick one row and multiply to that element of that row only. All right, this is clear.
Yes, sir.
Yes, sir.
Yes.
All right. So now you can check. I can pick determinant A from this row, right? Because 0 times determinant A is 0 only. So one determinant A from this row, one from this row, one from this row. All right. You can check reverse order also. If this is a number, I can multiply this in first row, this in second row, this in third row. I'll get this same determinant. This is clear now.
Yes, sir.
All right. Also, Ronaldo, check on me.
Yes, sir.
Yes,
All
sir.
right. Now, determinant of this identity matrix is one only. You can check. All right. You can try to find. You will get the answer one. So finally, what you are getting is determinant A times adjoint of A is equals to determinant A cube. This is cancelled. This becomes 2. So adjoint of A is determinant of A times 2. 2 is 3 minus 1, hence 4. Is this clear? The proof is clear, everyone?
Yes, sir.
Yes, sir.
All right, you can write it down. The proof. Done, everyone?
Done, sir.
All right. All right, let's write inverse of the matrix. Write down inverse of a matrix. A square matrix of order n is said to be invertible if there exists a matrix P of same order such that AP is equals to BA is equals to identity matrix. In that case, we say B is the inverse of matrix A. That is P inverse is equals to P. Write it down, I'll explain. Tell me when you are done writing.
Done, sir.
All right. So what inverse means? From childhood, you have seen the inverse of 5 is 1 upon 5. Why? Because if you multiply these two, you get 1, right? This is called inverse.
Yes,
Now,
sir.
in the case, right, in the cases of matrices, if you multiply any two matrix and you get identity matrix as the result, then 1 is the inverse of other matrix, right? 5 is the inverse of 1 upon 5, and 1 upon 5 is inverse of 5. The same way, if you multiply AB and you get identity matrix, then we can say B is the inverse of A, or A is the inverse of B. Is this clear?
Yes, sir.
So if they ever ask you, check if this is the inverse of this matrix or not, then just multiply those two, see if you get identity matrix. All right. Also, Ronaldo, Shikani, this is clear.
Yes, sir.
Yes,
All
sir.
right. Now there is a useful theorem here, theorem 5. A matrix A is invertible if and only if it is non-singular. All right. Let's see what this means. We are saying if a matrix is non-singular, then only we can find inverse. What is the proof? We know A times adjoint of A is equal to determinant of A times I. I can take this determinant to this side because this is a number only. So A times adjoint of A upon determinant of A is equal to I. Ronaldo, can you tell me this? This is a matrix or a number. Adjoint of A upon determinant of A. Is this a matrix or is this a number? Ronaldo, you have to answer this. Adjoint of A upon determinant of A. Is this a matrix or is this a number?
So it will be a number.
All right. It will be a number. All right. Kulsum, what about you? Is this a matrix or is this a number? All right. No answers. Krishna?
Sir, it's a, I think it's a matrix.
It's a matrix. All right. Let's see. Ronaldo, you can see adjoint of A is a matrix or a number.
A matrix.
Matrix. So if you multiply a number, right? The determinant of A is a number, and 1 upon determinant is also a number. If you multiply this with any matrix, then the final answer will also be a matrix, right? This number will be multiplied to all the elements. So this is a matrix. Let's call this B. So what I can see is A times B, I'm getting identity matrix. So can I say B is the inverse of A here? Yes or no? Everyone?
Yes, sir.
Right? So I can say what I can say is A inverse would be this matrix here, 1 upon determinant A times adjoint of A. This will be inverse of A. Here we can see that if we have to find inverse of A, then this cannot be 0 because 1 upon 0 is not defined. We cannot find the answer, right? That is why this theorem says if you have to find the inverse of any matrix, then that must be a non-singular matrix. Is this clear, everyone?
Yes, sir.
All right. Kusum, Ronaldo, Shikani.
Yes, sir.
Yes, sir.
All right. You can also note down one important thing here. This theorem provides a very important formula for finding inverse, right? Inverse of any matrix would be 1 upon determinant of A times adjoint of A. All right. If they ever ask you to find inverse of any matrix, this is the way to go. All right. Find adjoint of matrix A, divide by determinant of A. You'll get the answer. All right. Is this clear, everyone? Ronaldo, Krishna, Shigani, Kusum?
Yes, sir.
Yes, sir.
All right. Note it down.
So what is after is a very important formula too.
For finding inverse of a matrix. Done with this?
Yes, sir.
All right. Let's solve one question. Find the inverse of matrix 2 minus 1, 3, 4. All right. Solve this question. You know the formula. All right. 1 upon the determinant of A times adjoint of A. Solve this. Tell me when you are done.
Done, sir.
Done, anyone?
Yes, sir. Done.
All right. Ronaldo, Kulsum,
Done, sir.
then
I just want to last step.
no need for me to solve this, I guess.
Yes, sir.
Done, Ronaldo.
Yes, sir. No.
Let's solve another question. If A equals to 1, 3, 3, 1, 4, 3, 1, 3, 4, then verify that A times adjoint of A is equals to determinant of A times I. Also find A inverse. Alright. So what does verify means? This is LHS, this is RHS. Solve both, show that they are equal. Then after that, find A inverse. Alright. Very easy question. I'll give you 4 minutes for this. Tell me when you're done. Anyone solve this?
No suggestion.
All right.
Done, sir.
All right. What is the answer? A
Sir,
inverse.
for adjoint, for A inverse,
Yes.
so it's 7 minus 3 minus 3 minus 1 1 0 minus 1 0 1.
Everyone solve this? Ronaldo, Kulsum, Shikani.
Yes, sir.
All right. Ronaldo, what about you?
Yes, sir.
So, no need for me to solve this. Do I have to solve this or let's move on? What do you guys prefer?
Sir, is there any shortcut to solve faster?
No, there is actually no shortcut. You can get faster by solving more and more things. Like the most time you take is to find adjoint, right?
Yes, sir.
So the more practice you do, the faster you become. Right?
Okay, sir.
Yeah, it feels like a lot of time, but you will see till the exams you will be solving these questions in 2 minutes, under 2 minutes. In fact. Let's see another question. If A equals to 2, 3, 1, minus 4, and B equals to 1, minus 2, minus 1, 3, then verify that AB inverse is equals to B inverse A inverse. Alright, here you have to find AB, then AB inverse, B inverse, A inverse, then multiplication of these two, and see LHS equals to RHS. So this is a long question, you can say, but this is a matrix of order 2, so a bit easier. All right, that is all. I'll give you a few minutes.
Done, sir.
All right. Any doubts on this? Also, any doubts on this? Any step?
No, sir. No doubt.
No doubts. All right. Krishna, Ronaldo, what about you?
So can you give just 1 minute?
All right.
Done, sir.
All right. Ronaldo, have you solved this?
Yes, sir.
All right. No doubts, right?
No, sir.
All right. Let's solve another question. This is a new type of question. All right. Show that the matrix A equals to 2, 3, 1, 2 satisfies the equation A square minus 4A plus I equals to 0. 0 here is null matrix. And using this equation, find A inverse. Okay. You have to solve the first part. Till this equation, prove that this is right. LHS equals to RHS. The A inverse part, I'll be solving. Tell me when you have solved till this. All right, first part. All right, Krishna, Ronaldo.
Okay, sir.
All right.
Done, sir.
All right. So you have solved this A square minus 4A plus I equals to 0. Right?
Yes, sir.
Yes, sir.
All right. Now, how to find A inverse using this? So the first step would be to, I can write A square as A times A. This is minus 4 times A plus I equals to 0. Now, multiplying A inverse to whole equation. So I can write A inverse times A times A 4 plus A I equals to A inverse 0. This is clear?
Yes, sir.
Everyone, this is all right. Now I can take these two together. What will be the answer here? A inverse times A.
1 identity matrix.
Identity matrix. So I times A minus, I can take this 4 outside. So 4 times A inverse A would be again I plus A inverse times I will be A inverse, right? Any matrix into identity matrix is that matrix itself. This is equal to 0. Any doubts in this line?
No, sir.
So this is again A matrix minus 4i plus A inverse equals to 0. So from here we can write A inverse is equals to 4i minus A. So 4i is 1001 and A matrix. What is A matrix? Can anyone tell me?
2 3 1 2.
All right. So now this is 4004 minus 2312. So this is 2 minus 3 minus 1 and 2. So this will be A inverse. All right, this is clear?
Yes, sir.
All right. Also, Ronaldo,
Yes, sir.
Yes, sir.
all right, note it down. All right. So this is another way to find A inverse.
Done, sir.
All right. Let's solve another question. For the matrix A equals to 3175, find x and y such that a square plus xi equals to y a. Hence, find A inverse. All right. Very easy question. Try to solve this.
Done, sir.
All right. What is X and Y?
So I think it is 8 and 8. Both are 8.
All right. And A inverse.
So 1 by 8 into 5 minus 1 minus 7, 3.
1 by 8, then 5, then minus 1.
No, not like that, sir. I didn't multiply the determinant of it. That's why.
All right, all right. So you are saying 1 by 8, and then this is 5 minus 1.
Minus 7, 3.
All right. Anyone else who saw this?
Yes, sir, I've done it.
All right. Same answer. Ronaldo.
Yes, sir.
All right. So what about you?
I'm doing it, sir. I made a mistake somewhere.
And how did you guys find A inverse? Did you like you all did this matrix A and determinant A? Or did anyone use this equation also? Krishna?
No, sir. I did with the determinant first method.
All right. Ronaldo?
Yes, sir, me too.
All right. But try using this equation. All right. I told you in the previous question how to use this equation. All right. Because in this type of question, they have given you this equation to find A inverse. All right. And this is extra effort. You have to find adjoint than this. But you can see, I can do this. A square plus 8i is equals to 8a. This will be equation. Now again, this I can write 8 times a plus 8i equals to 8a multiplying A inverse. So A inverse A plus 8 A inverse I is equals to 8 A inverse. All right. So this will be A inverse A. Now this is I times A is A plus, there is some error I guess. So this is 8 A inverse is equals to 8i. So 8 A inverse will be 8i minus A. So A inverse will be 1 upon 8, 8i minus A. Just put the value of 8i and A, will get the answer. All right. This is the way to go. You don't have to find adjoint or determinant or anything. All right.
Yes, sir.
Ronaldo, is this clear?
Yes, sir.
All right. Pulsum.
Yes, sir.
All right. Let's move on. Find a 2 cross 2 matrix B such that B times 1 minus 2 1 4 is equals to 6 0 0 6. All right. This is your question to solve. Right. This type of questions we solved in matrices also, if you remember Krishna, Ronaldo.
Yes, sir.
But we are going to learn another way to solve. The first method was to assume x, y, w, z, or a, b, c, d, right? Then solving 4 equations. But now what we can do, I can take this matrix as A. All right. Suppose this is A matrix. So this is B A is equals to 6i. Is this okay? Everyone?
Yes, sir.
I have to find I have to find B only, right? I have to find B matrix. So if I remove this A matrix somehow, I'll get B matrix. So what I can do, multiplying by A inverse. So I can write BA times A inverse is equal to 6A inverse. Is this step clear, everyone?
Yes.
So this will be B times I is equal to 6 times A inverse. So B will be this is equal to 6 times A inverse. Now you can find A inverse and get the answer. All right, this is A matrix. Is this method clear?
Yes, sir.
Okay. Ronaldo Kulsum, is this clear?
Yes, sir.
All right. So please tell me the answer. Find A inverse, multiply by 6, and tell me what you get.
Done, sir.
All right. What is matrix B?
So 4, 2, minus 1, 1.
Everyone got the same answer.
Yes, sir.
All right.
So it's
So this
minus
method
1
is
and 1.
yes, minus 1 and 1, right? Yes, minus. All right. Let's solve another question. A equals to 0, 1, 3, 1, 2, x, 2, 3, but A inverse equals to 1 by 2 minus 4, 5 by 2 minus 1 by 2, c minus 2 by 2, 1 by 2, y, 1 by 2. Find x, y. Alright, this is your question. Try to solve. No hint is given. Tell me when you are done.
Done, sir.
What is the answer?
So x is 1 and y is -1.
X is 1 and y is -1. All right. Ronaldo, Kulsum, Shikani. Ronaldo, have you solved this? Kulsum,
I didn't really understand, sir.
didn't really understand. All right, let's see. They've given you A and A inverse, and you have to find the value of X and Y. So what you can do here is, we know that A times A inverse is identity matrix, right, Kulsum?
Yes, sir.
So if we multiply this matrix and this matrix, we can compare this with identity matrix. So the first step is to multiply these two matrices. So A matrix here is 0, 1, 3, 1, 2, x, 2, 3, 1. Let's multiply this with A inverse. So you know matrix multiplication, right? Also,
Yes, sir.
all right. So 0 times half is 0, plus 1 times minus half is minus half. 3 times this is 3 by 2. This is first element. Second one will be 0, 3 plus 3 by, then 0 minus 3 by 2 plus 3 by 2. All right. Second element would be 1 by 2 minus 1 plus x by 2, then minus 4 plus 6 plus x by, then 5 by 2 minus 3 plus x by 2. Okay. Now 1 minus 3 by 2 plus 1 by 2 minus 8 plus 9 plus 5, 5 minus 9 by 2 plus 1 by 2. Is this right, Krishna?
Yes, sir.
This we can compare with identity matrix, which means this is equal to 1 0 0 0 1 0 0 0 1. All right. Now just take this is equal to 0. So x by 2 minus half is equal to 0. Supposed to cancel, x is equal to 1. And take this equation, y minus 1 is equal to 0 plus 1 is equal to 0. So y equals to minus 1. All right. And you can put this value in each of this equation, each of this value, and we should get same answer for all of them. Then we can say x and y is 1 and minus 1. All right, Kulsum, is this clear?
Yes, sir.
All right, Ronaldo, done?
Yes, sir.
All right, Shekhani, I hope this is clear to you also.
Sir,
All right then. So adjoint of matrix, inverse of matrix, this is all clear to you? Everyone, this is clear?
Yes, sir.
Yes, sir.
All right then. So this is all for today's class. All right. In the next class, we'll learn more about some topics. All right. We'll finish this chapter in next 2 classes. All right.
Okay, sir.
All right then. See you in the next class, and please keep revising. All right.
Thank you, sir.